Let's consider a particle that has a position given by this function. My position as a function of time is equal to 3 times time plus 0.5 times time to the third in meters. So this means that my result when I evaluate this will be in meters. In order for that to be true, we kind of have to specify what units we plug in our time with. So we're going to say this is true for when we plug in time in seconds. All right, so we want to know the instantaneous velocity at 2 seconds. How do we do that? Well, you can plot this and then try and find the slope at that point. And here we're going to do essentially that, just doing it using calculus and some algebra here. So we'll start with my knowledge of my velocity. My instantaneous velocity is the time derivative of position. That means that I take the derivative with respect to time of this function x as a function of time. So I can say it's the derivative with respect to time of, and I'll just plug in this function, 3t plus 0.5 t cubed. So I just need to evaluate this. In case you haven't evaluated a lot of integrals, I'll tell you how do we do this. Well, you can break this down into two different things and say this is the same thing as the time derivative of 3t plus the time derivative of 0.5 t cubed. And now we need to know how to evaluate each individual one of those. And here's the general rule. I'll just write it over here. When you take the derivative with respect to time of some constant times the time raised to some power n, the rule that you use is the constant still hangs out, and you multiply by the power. So the constant hangs out, we multiply by the power, and then we end up with time to the n minus 1 power. So basically, you multiply by the exponent, and then subtract 1 from the exponent, and that will take the derivative here. So that's the rule for when you have the derivative of some variable and your function is of this form, that variable raised to some power. All right, so let's evaluate this here. 3 times time. Well, this is time to the 1 power, right? Because it's just 1 time there. So I can multiply by 1. I still have 3. Then I subtract 1 and I get time to the 1 minus 1, or time to the 0. So anything raised to the 0 power is just 1, so time goes away. This leaves us with, from the first term, we end up with 3. Then from the second term, we have 3 times 0.5. That gives us half of 3, or 1.5. And then times time to the 3 minus 2 power, 3 minus 1 power. Remember, we subtract 1. And 3 minus 1 is 2. So we end up with a function 3 plus 1.5 t squared. So that's my velocity as a function of time. And now I want to evaluate that at time equals 2 seconds. So I say, hey, my velocity as a function of time is this. And one thing I'll point out is that here we had units of meters in our position. Finally now, when we take the derivative with respect to time, you're dividing by a time. So whatever units your time we're in, we divide by that unit-wise. So this will give me in units of meters per second. So let's evaluate this by plugging in my time value of 2 seconds and say my velocity evaluated at a time equal to 2 seconds is going to be 3 plus 1.5 times that time of 2 seconds squared. And because of how we're doing this, we don't have the units on these coefficients. We're just saying the result of this will be in meters per second. So we plug that in, you get 4 times 1.5 plus 3, so that's 6 plus 3, or 9, with units of meters per second. Lovely, so that's the instantaneous velocity at 2 seconds. What if I want the average velocity between 1 and 3 seconds? Well, we can go back and do our average velocity calculation. Say my average velocity is my final position minus my initial position divided by the elapsed time. So the elapsed time we know, 3 minus 1 gives us 2. But now for the positions, we need to evaluate those. We do that by evaluating my function here. So x at 1 second, x evaluated at 1 second, time equals 1 second, gives us 3 times 1 plus 0.5 times 1 cubed. 1 cubed is still just 1. The units of this should be meters. So that ends up with a value of 3.5 meters. Then we evaluate this at 3 seconds as well. So that's 3 times 3 plus 0.5 times 3 cubed. This gives us 927. Half of 27 plus another 9 should give us, again, these are units of meters, should give us 22.5 meters. We can now plug those into our expression over here and say this is going to be 22.5 meters minus 3.5 meters. So that's my differences in positions there. And then divide by the elapsed time, so that's 3 seconds minus 1 second. And we get, when we evaluate that, we should get something like 9.5 meters per second. So that's my average velocity over that time interval.